Greetings and welcome, friends. This is part 2, I guess we could call it, of the ambiguous case of the law of sines. And today we're specifically going to look at the situations in which I have two triangles being formed. So I'm going to write, for example, solve the triangles. All right. Solve the triangles, and suppose my given information, let's say angle A is 51 degrees, let's say little a is equal to 40, and let's say little c is equal to 50. Now I'm going to try to draw a really good picture of this if I can. So 51 degrees, well that's, and actually I'm going to draw a big picture of this if we could. So 51 degrees is a little bit bigger than 45 degrees, right? So here's my angle A. 51 degrees, something like that. The adjacent length would be 50. All right, there we go. And then I've got this 40 hanging out, right? And I'm actually anticipating that this is going to be a two triangle situation. And what I want to point out is that there's actually, when I swing it, it's going to land in two spots. It could land there, or it could land there. All right. So for my original sketch run through, this is going to be kind of what my triangle looks like. And we're going to think about this in two separate cases. All right. One of them is going to be the larger, just kind of plain old acute triangle. And then the other is going to be this sliver over here. All right. So let's first solve the big one here. I might actually draw a separate sketch for each of them. So case 1 is this case. So A, B, C, because I'm going to have a whole bunch of stuff drawn all over it, possibly in a second. And then 40. So here's case 1. So let's use our regular old law of sines skill set to solve these. What's the first thing I could solve in this problem? Angle B, how would I solve for angle B? Yeah, I could match those, but the problem is to find angle B, I'd also have to have side B. So I can't actually... I could find angle C. Actually, angle C is the only thing I could solve first because I have to have at least one part of the pair to work with. So I'm going to say sine of angle C over 50, is equal to sine of 51 degrees over 40. And then solve. You guys are so good at law of sines by now, I imagine. I mean, this is like kind of the third day we've spent on it in general. So we'd have sine of C is equal to 50 40ths times sine of 51. And to get C by itself, we sine inverse both sides. Sinverse. Sine inverse. So we would get C is equal to, here we go, we're all good at this, sine inverse of 50 divided by 40 times sine of 51, double close parentheses. And I get angle C is 76.27 degrees. All right, so there's my 76.27 degrees, right? So now I can find angle B. How do I find angle B? Well, I don't have side B, so I can't use the law of sines. Yeah, 180 minus A plus C, right? So B is just going to equal about 180 minus second answer plus, what was it, 51, close parentheses. And I get 52.73 degrees. So this is actually going to be close to an isosceles. I mean, 51 and 52.73. It's going to be kind of close-ish. And then to find side B, let's see, so I guess I can label that 52.73 degrees. So side B I'm expecting to be the medium-lengthed side, and I could do that using law of sines again. So B over sine of 52.73 is going to equal, and I'll compare it to my original set, the A's in this case. So that's 40 over sine of 51 degrees. So to solve this, I can now multiply both sides by sine 52.73 degrees. Multiply by sine of 52.73 degrees, right. And I'll get little b is equal to, or about technically. So that's 40 times sine of, actually I could just hit second answer, it happens to still be in my calculator. Close parentheses, divided by sine of 51, close parentheses, and I get 40.96. Something like that. Which notice is not a lot different than the 40 that I was talking about, and that's because these two angles were pretty close together, that their sides are going to be close together as well. So that is only one of my possible triangles, okay? But there's two possible cases, and the reason we could have figured that out is using our previous skill set, finding the height, and we would have realized that side A here was longer than the height but shorter than the adjacent, and it's a two triangle situation. So what I want to point out is we've just found angle C, we found this angle B, and all sorts of stuff, but that's not the only possible case. To find our second case, well, this is going to be angle C for our second case. And in fact, we'll call it C prime, or I'll put like a little apostrophe next to the C, or a little tick mark almost. So that will be C prime. And let's think about C prime here. All right, this is angle C. If this is 40 degrees, what is this length? I'm sorry, 40 degrees, 40 units. What is this length here?
40.
It's also 40 because it still is the opposite from A, and that's given to us. So that must be congruent. So this is also 40. All right, so 40, 40. So little a, big A, and let's see, little c are all going to still be the same, right? This is C. But what's going to change on us now? What's going to happen? How could I find C prime for my new situation here? Well, I'll tell you. It turns out, because this is 40 and this is 40, base angles theorem says that if you have two sides that are congruent, then the angles opposite those are congruent. So I'm kind of looking at this triangle right here, this isosceles, even though it's not either of my two solutions. But I can realize that this angle right here, this green one, is going to be congruent to this angle here, because this was 40 and this was 40. And notice that this angle and this angle, what do those have in common? What do those do? They add up to 180 degrees because they are what's called a linear pair, right? When you combine them, they're supplementary because they form a line. Linear pair postulate says that, right? Angles that form a linear pair are supplementary, meaning they add up to 180 degrees. So if I want to find C prime, that's going to be my first move, is just do 180 minus C will equal C prime. All right. Now, that's not the only angle that will change. It turns out angle B is also going to change. Angle B is now going to be this little sliver. Because look at it. C went from an acute angle and is now going to be an obtuse angle. And B went from an acute angle to, it'll have to be even smaller, because in my purple triangle, this is going to have to be just a smaller angle to still add up to the total 180. So let me draw a new sketch of what this triangle is going to look like. So it's going to be an obtuse triangle. Something like this. Here's angle A, the 51 degrees. What was this side length? Was it 50 or 40? For side C, 50. For this one. Here's 40. And I'm now going to label this angle C prime and this angle B prime, and then I'm missing one new side length. Did my side length change?
Yeah.
Yeah, check out this. My side length for, what side is that?
B.
Yeah, that's side B. Little b is going to be much shorter than it was originally, right? So that will refer to as B prime. Right, so there's big B prime is the smaller of the two angles. Little b prime is going to be the smaller of the two sides. And our trick to finding angle C, all right, is realizing that angle C is a linear pair with or C prime is a linear pair with C. So that's our first trick. So I'll say that C prime is equal to 180 minus C. All right, that's going to be true for whatever kind of our little base angles happen to be. So it's not always necessarily going to be C. If I label that as B's originally, that would be different. But let's see. So what is C prime going to be? C prime is going to be 180 minus what was angle C? We found it was 76.27. So C prime is going to be what, 103 point something? Makes sense. Sounds like a radio station right there, FM. So there's C prime. So now that I know C prime, 103 degrees-ish, now I can find B prime. And I'll find B prime just like I did back in the day. B prime is going to equal 180 minus angle A plus angle C prime. All right, and I actually do recommend drawing the two triangles just so it doesn't get confusing. I mean, I have multiple colors here, so maybe this sketch isn't that confusing for you, but it very well could get that confusing. So let's see, so B prime, I'm expecting to be smaller than angle B, right? So that's going to be 180 minus the, in parentheses, the second answer, 103.73, plus whatever angle A was, which was 51, close parentheses, and I get B prime is equal to 25.27 degrees. And now, how could I find little b prime? Law of sines. So little b prime over the sine of big B prime, sine 25.27. I don't like the way that 2 came out. 27 degrees equals, and I'll compare it to the ratio of the a's. And notice, I just want to point out my given information stayed the same, right? Big A, little c are all still the same for this triangle. So I didn't make up a new triangle on my own. This is literally another possible triangle that would have formed. So, so this is still the same value. So 40 over sine of 51 degrees. So to solve this, I'd multiply both sides by the sine of 25.27. So multiply by sine of 25.227 degrees. And I'll get little b prime equals, let's see, 40 times sine of second answer, close parentheses, divided by sine of 51, close parentheses. And I get 21.97. And I just want to point out, with my new setup, let's see if this makes sense. So I've got the biggest angle is opposite the biggest side, right? The smallest side opposite the smallest angle, and the mediumest is opposite the mediumest. So it's not a guaranteed check when you do that, but it'll at least catch some errors. And actually most of your errors, or the main errors typically will be, oh, I divided by the sine of an angle instead of multiplied or something like that. And that usually will end up messing up that ratio there. So I've solved for both possible triangles, and that's it. All right, that's it. So I recommend in drawing your sketch, you break it up into two separate ones in order to do these problems, and it ends up not being terribly difficult. One of the big ideas is this relationship between your obtuse angle and its previously thought acute version, is that they happen to be supplementary. All right, so that's kind of the big idea right there. So anyways, thanks for watching, Internet friends. Have a great day. Bye-bye.